Welcome, everybody. Welcome to the joint workshop on speeding up LLM development with Gretel and Predibase. We're really excited to have you here with us. Let's get a few logistics out of the way. So this workshop will be recorded and made available on demand within 24 hours. Please feel free to submit your questions via the Q&A feature in Zoom. Our team will try to answer at the end as many questions as we can. If we do not answer your question, feel free to follow up with both the Gretel and Predibase teams after the workshop. I'm Yev Meyer, Chief Scientist at Gretel, and today I'm joined by Alex Trustinsky from Predibase, and we're really excited to talk to you about how you can leverage Gretel and Predibase to speed up LLM development. But first, let's start out by asking why we're here. In 2024 and even 2023 and before that, every company has started becoming an AI company. You probably have seen folks mention that AI won't replace humans, but other humans using AI will. And very much the same is true of businesses. AI won't kill businesses, but other businesses using AI will. And companies today are really looking to differentiate in terms of building their products with generative AI. And the question that they face is, how can they do that effectively, given very broad access to LLMs via an API? And some companies are starting to look into developing custom models that are built with proprietary data. Jay Alomar from Cohere published a wonderful blog post a while back called AI is Eating the World, where he touched on business modes that companies can look at in the age of AI, generative AI specifically. And in addition to traditional business modes around distribution, domain expertise, what he really suggests is that companies building in the application layer should try to sink their teeth and claws into the custom model and proprietary data. Also, recently, Clem DeLong, CEO of Hugging Face, posted this in response to a TechCrunch article saying that the best model is the one you train. And the important caveat here is that it's the model that you train on your own data. So before we, we will have a few polls at the end, but really curious to hear from this group how many people are trying to develop custom models, how many are trying to use private data. So be on the lookout for a poll at the end of this workshop. So great, we have a solution. We want to differentiate our applications by building custom models. One of the most promising ways of doing that is to fine-tune LLMs. Almost no company is training LLMs from scratch because doing so is really expensive. And so this is wonderful. We just need training data and some fine-tuning. And typically when companies go through this, they go through several stages of LLM development grief. You get really excited about the possibilities, what can be done. You start thinking a little bit deeper about what are the actual steps that need to be performed. And then you start crying on shoulders of your coworkers because you realize there is so much that needs to be done. You might get a little frustrated, or you also might have a eureka moment. And there are really two big buckets of problems. The first one is that everyone today is very much data poor. What do we mean by that? We mean that oftentimes when teams are trying to build products or features, they literally have no data to work with. Imagine a scenario going from 0 to 1 when you don't have any data. How do you get high quality data to be able to fine-tune a model, develop a custom model? You may also be jumping through a lot of hoops to access sensitive data or data that has potentially PII in it. This is very much top of mind for enterprises. You're also typically dealing with really messy data. This is almost always true, and teams spend up to 80% of their time cleaning data. You also might be labeling data, but that tends to be quite expensive and quite a time sink as well, because you're fundamentally constrained by how quickly humans can do this. The second bucket of problems is that everyone today is still very much GPU poor. Things have improved in terms of supply chain, but GPUs are still pretty expensive. They're hard to secure. And more importantly, it's hard to have a good fine-tuning stack. It's also pretty challenging to keep up with all the fine-tuning developments, all the latest fine-tuning techniques that keep coming out on a daily basis. And teams end up facing suboptimal performance and running into quite an expenditure in developing this. And so the end result is that in the best case, teams spend weeks or months developing models. In the worst case, a project can join a graveyard of projects just never making it to production. And so there is a better way, and that's what we wanted to talk to you about how you can leverage Gretel and Predibase. So first, let's dive into Gretel. Gretel is the synthetic data platform for developers. What we're trying to do is make it as easy to work with synthetic data as possible. We are trying to make synthetic data better than real data, and we're already making a lot of progress with that. So you're able to get exactly the data you need. You're able to get it very quickly. You're able to craft it from natural language prompts. You're able to generate data that is differentially private by design, and you're able to generate higher quality data for your applications. So some of the main benefits with respect to Gretel is that you can generate high quality data, which also means that you need less of it. You're able to design in a true iterative fashion data for your specific task. And so imagine being able to make patterns in real data without privacy risks, address class imbalances, tackle ethics and biases. Synthetics really give you those levers for the first time to address such issues head on. You're also able to improve diversity. And if you don't have any data, to really go from 0 to 1 for your project. Because of all of this, you and your team are able to innovate faster, and you shorten the time it takes to bring a project to production. You also lower the costs because you don't have to necessarily label the data. And you own the data so you can use it for commercial purposes. And really, all of this results and boils down to really us shaping the data-centric AI movement. What we're witnessing in 2024 is a renewed focus on data quality. So looking across some of the latest developments with respect to LLMs, be it the Gemini family of models or the Phi 2 series or Phi 3 series of models, we're seeing massive model performance gains. And these gains as a result of using synthetic data. And these gains are reaffirming this data-centric approach to AI, which Andrew Ng very eloquently put as the discipline of systematically engineering the data you need to build a successful AI system. How do we do it? Well, we're doing it with something called Gretel Navigator. And Gretel Navigator is the first compound AI system designed specifically to generate high-quality data using natural language prompts. There are many components working in tandem as part of Gretel Navigator. So think of agentic workflow, purpose-built data models, task planning to figure out which of these models, which tools to use, best-of-breed data tools, and also best data generation practices. Gretel Navigator is currently in public preview. We invite you to try it out. And as part of this workshop, we wanted to dive into the text-to-SQL case study to demonstrate how we were able to leverage Gretel Navigator to generate our synthetic text-to-SQL dataset. So the synthetic text-to-SQL dataset is something we released about a month ago. We published it on Hugging Face. It very quickly became the #1 trending dataset on Hugging Face. And Clem DeLong, CEO of Hugging Face, called out this work, calling it beautiful. And really, the reason this dataset created so many waves is because it was and still is the world's largest synthetic open source text-to-SQL dataset. Now, what is text-to-SQL? Just a little bit of context for those folks who might not be familiar. The context here is that we really want to enable users to interact with databases using natural language. Most companies out there have some sort of database on the back end. It could be a MySQL database, Postgres database. It could be a data warehouse or a data lake where they have data sitting. And typically to interact with this data, one needs to know SQL to do that effectively. And SQL itself ends up creating quite a bit of barrier for most users who are not familiar with it. And so imagine instead of writing a SQL query, being able to just ask a question or give an instruction in natural language. So here's an example. If you want to find out what are the names and prices of certain products, and let's say in this case, under $500, and you want to sort them, you could just ask that instead of writing a SQL query. Now, this SQL query is pretty simple, but SQL queries, as many of you know, can get quite complex. And so this is the context. How can we develop a model? How can we fine-tune a model to do this effectively? And so the question becomes, how do we generate a data set? How do we generate a data set that would let us move the needle with respect to text-to-SQL? And some of the things for us to consider really from first principles, and this applies not just to this specific task, but really any task when it comes to generating data. What is the best tool for the job? Is it just one tool? Is it multiple tools? What do we do about diversity of data? We probably want to have a variety of domains, variety of use cases. If we're talking about SQL, one can use SQL for defining tables, views in databases. One can use it to retrieve data. One can use it to manipulate data. You can also be looking at different SQL complexity levels. So there are really many different considerations with respect to any data set, and really any data set is Snowflake in that sense. With respect to SQL, we want to make sure that SQL is grounded in the database context. We want to make sure that the SQL we generate doesn't just look plausible, but it actually works, right? And in the context of code and SQL specifically, what that means is that this SQL is parsable, that SQL is valid. And we probably also want to perform basic data hygiene, right? Meaning we want to duplicate data, we want to possibly handle outliers, do class imbalancing. And then there is so much more to just generating data and synthetic data in general. And so this is precisely the vision behind the compiled AI system we're building and the vision behind Gretel Navigator. Real quick, some stats on the text-to-SQL dataset. This dataset contains over 100,000 records, containing 23 million tokens. 12 million, or roughly half of that, are SQL tokens. We're covering 100 distinct domains, and really a gamut of different SQL tasks, everything from data definition, manipulation, analytics and reporting, retrieval. We're also including quite a few complexity levels with respect to SQL. So it's everything from window functions, aggregations, joins, be it single or multiple joins, set operations. And last but not least, we're including database context because we want the SQL query to be grounded in the specifics of the database. And we're also including natural language explanations because quite often it's not enough just to look at the SQL. You want to be looking and understanding what that SQL does too. We have evaluated the quality of the text-to-SQL dataset using kind of an independent LLM as a judge evaluation technique. We compared it to one of the most heavily used text-to-SQL datasets that is actually based on real-world data. And as somewhat expected, we see much better compliance with SQL standards for the synthetic dataset. We see much improved SQL correctness and adherence to instructions too. And so you can really see quality shine through with respect to synthetic data. I will quickly link to resources here to Gretel Navigator, so you can sign up and give it a try. We also have our CLI SDK client. You can access it on GitHub or on PyPy. And you can also take a look at quite a few use cases across our blogs and workshops and webinars. All of these resources will be available to you in the resources section of this workshop. And let's quickly dive into a demo. So let me just kick this off real quick. This particular demo is done in Databricks. You're not confined to Databricks. This is just to show how you can leverage this pretty much anywhere. You can be using this directly in your code. You can be using this in Colab. You could be using this in your Jupyter Notebook environment. This is not the full code to generate the dataset. This is meant just to give you a taste for what is possible with Gretel Navigator and how easy it is to generate data. So all you have to do is grab your Gretel API key, which I'm going to do right here. And just quickly explain, so we're installing a Gretel client. We're doing a few imports, providing our Gretel API key. What we're doing here is specifying a few generation parameters. So in this simple example, I want to generate this across 10 different domains. I would like to generate the data for the domains using Gretel itself. And so there's a simple natural language prompt here asking for the domain and domain description. We're able to generate this pretty quickly, as you can see. And so here are some of the domain descriptions. We're looking at healthcare, technology, hospitality, etc. There's a description of the data for each of these domains. It could be that you want to bring some of the subject matter expertise for your specific task, and you want to provide different levels of user proficiency, different levels of SQL complexity, different types of SQL tasks, right? So you're able to do all of this. And the idea really is to see the data, right? You want to have these different levers that you want to control, and that's what Gretel allows us to do. We're able to specify the data seeds and generate specific data that we want for the task at hand. And so here's an example of the data seeding we're doing. So we're looking at different domains, different descriptions, user level, SQL complexity, SQL tasks. And now we're going to go ahead and generate all of this data using Gretel Navigator. And so the idea here is that we want to generate natural language prompt. We want to generate database context, SQL query, and an explanation for that SQL. And so this is almost done. We're going to give it just a little bit more time, and we'll see the data that is generated by Gretel. And one important thing to emphasize is really the design considerations behind all of this. As you can see, you're able to specify any number of columns, any sort of description, right? So you're not limited to just 3 or 4 columns. You can ask to generate as many columns as you want. Here we go. We generated records, and let me just expand this a little bit to show you what this looks like. So we're looking at data, and in this data we have, in addition to the seeding that we have done, we have the prompt, the database context, the specific SQL, and explanation of that SQL, and just looking at a few records. This is an example in agriculture, where we're looking at data on crop yields. And what we're interested in knowing is what is the average yield of wheat in each country. And so we have our context for the database, and we have the SQL, which is selecting country, average yield, performing a few joins, and really helping you answer that question. So this is just a very quick demo. As you saw, this took only a few minutes to generate quite a bit of data. And with that, let me kick things over to Alex from Predibase. Alex, feel free to hop in.
Fine-tuning large language models and serving them using high-quality data sets. So, hello, everyone. I am Alex, very excited to be here. Big thank you to the Gretel AI team for inviting me to talk about efficiently fine-tuning and serving open source large language models. I would like to propose that we first review some key concepts and then dive into the actual code walkthrough, showing you how to easily build your own set of fine-tuned models of high quality. I will first offer an introduction to our recent LoRaLand launch and an overview of adapters and why they are the future of fine-tuning. That will set the context for us to go into the engineering aspects of LLM fine-tuning, the open source frameworks, the Predibase service, and then an actual code walkthrough for fine-tuning adapters for helping us, engineers, build the SQL queries for various practical application scenarios. Before joining Predibase, I was an early engineer at a data quality company. And as one of my projects, I worked on the database layer for the company's popular open source library. And boy, did I wish that this workshop tutorial happened in 2018. While we cannot easily travel back in time, we can at least take part in building a bright future for data analysts and software engineers. Awesome. So let's talk about LoRaLand and some of the underlying motivations. LoRaLand is our playground that shows how we fine-tuned 25 models that rival GPT-4. By rival, we mean they're at an equal or better performance. And today, I couldn't be more excited to show you how you can build your own version of LoRaLand in the database management system domain, a handy SQL copilot. Before we dive into LoRa land and why we built it, I think that it would be helpful to take a step back and see how most teams have started experimenting with large language models. And we see that most teams start with a commercial LLM like OpenAI or Anthropic, and the appeal is very clear. These are large language models with trillions of parameters, complex reasoning engines at your fingertips, just an API call away. However, we start to see very quickly that many teams run into hurdles with these commercial LLMs. Cost. Some companies are spending upwards of millions of dollars on OpenAI once they have it in production. Latency. Because these models are so large, you're stuck with whatever speeds the providers give you. For latency-sensitive real-time use cases, getting a response from GPT-4 is 5-10 seconds, just not going to be good enough. And these models are not yours. If you believe that your data and your models are your intellectual property, then it's clear that having ownership of your models is the key to building a defensible generative AI strategy. So if OpenAI isn't the future, then what is, right? Why not just keep using OpenAI for everything? Proof of concept, prototyping, development, production? Well, the truth of the matter is that actually relying on OpenAI as part of a real commercial grade application in a production environment is problematic. It's okay to start with OpenAI to get experience with LLMs, but using smaller, fine-tuned open source models when you're ready to move to production often provides better trade-offs. When we talk to organizations today, we find that using large models like GPT-4 is fine, but what developers are really trying to do is solve specific tasks, like building a question and answer type chatbot, build a text classifier or summarizer, generate structured output like JSON or in our case, SQL. And by using open source models, you can immediately see several key benefits. You own your models, you stop sending your data to these external commercial LLM services, and you control these smaller and faster LLMs. So our recommended approach is LLM fine-tuning. Here is how it works at a very high level. Large language models are good generalists, but they don't specialize very well. They're trained on many different tasks, so they know a bit about everything, kind of like jacks of all trades, but not enough about anything specific. Nevertheless, it turns out that there are ways in which we can also train them to solve particular tasks very, very well. That particular task and nothing else, that is called fine-tuning. You start with everything the model knows and adjust its knowledge to help it improve on the one task that we care about. So the premise of fine-tuning is base models are retrained on gigantic data sets. They're very general, not able to perform well on specialized tasks, but fine-tuning does accomplish this. And a big advantage of the fine-tuning approach is that as long as the data sets are high quality, they do not need to be very large. Typically, small, high-quality data sets with around 20,000 samples are sufficient to get a good fine-tuned model performance. There are a couple of main approaches for fine-tuning. We will focus on parameter-efficient fine-tuning, or PEFT for short. And PEFT became popular because it has this notion of adapters that occupy just 1% of the total model parameters, but the results are really good on a very large variety of tasks. And it might seem counterintuitive. Why wouldn't you adapt all the weights? But it turns out that the base model has most of the general knowledge, and that's already baked into it. We need to tweak only a few weights to teach it our task. And another reason at a more fundamental level, if we were to modify all weights, the catastrophic forgetting might happen. That's a common problem in machine learning. So by modifying only a small number of weights, we avoid the loss of such information as grammar and language semantics while it's learning on our particular task. And so over the past year, one such fine-tuning method became very popular because it works very well. It is called low rank adaptation, or LoRA for short. And in this technique, we introduce two tensors A and B. And when we do a forward pass, we use the original weights and these additional weights on the right. But when we do training or fine-tuning, we completely freeze the weights of the base model. We don't change them. They're frozen and untouched. We only update the LoRA adapter weights using the loss information, and that's how we accomplish the fine-tuning. And in a real example, here is JSON generation. We've run benchmarks comparing fine-tuned 7 billion parameter model against GPT-4, much larger. We found that not only was fine-tuning actually more accurate, but it was also 250 times smaller. It matters because if you compare Predibase to OpenAI, there's about 100 times price difference between us and GPT-4. So with open source LLMs, you're actually getting the best of both worlds, better performance at a fraction of the cost. And this works not only for JSON generation. In today's example, we will do the SQL data set fine-tuning. And so I present to you LoRA Land, our playground of fine-tuned adapters based on the Mistral 7 billion parameter model. There are different applications, mathematical tasks, headline generation, news summarization, named entity recognition, many more. It's a very effective showcase demonstrating why LoRA type of fine-tuning is popular. And we have seen it almost consistently over 1,000 models that we have fine-tuned across multiple data sets. LoRA is extremely competitive, and it's less than 1% of the total model size, and cheaper about 15 to 25 times to fine-tune and 10 to 12 times faster. So if there was ever a question of does fine-tuning work, I think that LoRA Land shows that the answer is a resounding yes. We saw on X that even Jan LeCun, chief scientist at Meta, quote tweeted our launch and has conviction that the future will indeed be one with many small fine-tuned models. And there are many more adapters on the LoRA Land page. You're welcome to try them yourself. And our team published a technical report on arXiv. It has been featured on Hugging Face and covered by industry trade magazines. It includes the results of our comprehensive study of fine-tuned models versus GPT-4. Even some influencers in the machine learning community find this paper helpful in their own work. We're now going to dive in a little bit deeper into how these systems operate. And when we talk about bringing these large models, LLM applications into production, there are two major components. One is responsible for fine-tuning, training. The other is responsible for inference. And there are many challenges to solve. The finite precision of floating point numbers with the GPUs, the accelerators, finite amount of memory that one has to grapple with. And so within these two main blocks, Predibase actually has two corresponding open source frameworks that we maintain. One is called Ludwig for fine-tuning, and the other is called LoRAX for efficiently serving many adapters with the same base model. And so Ludwig is a low-code framework. It's configuration-driven. You give it basically inputs and outputs, name of the base model, and it figures out a lot of the complexity by itself. That's why it's become very popular, because it makes the life of data scientists and machine learning practitioners a lot easier. It figures out GPU resources and optimizes the results for the predictions that will be served when the models that are fine-tuned are going to be put into your application. And LoRAX is for serving. It is extremely wasteful to deploy each fine-tuned adapter on its own in its own dedicated environment because the GPU will be largely underutilized. Instead, LoRAX takes the base model and packs at least 100 adapters to share that GPU resource and swaps them in and out as needed. If one is idle, it will be swapped out for the adapter that's needed for the given use case. It's kind of like how virtual memory works in an operating system. So it's very efficient because you can have at least 100 fine-tuned adapters for a given base model accommodated on the same GPU. So it gives incredible cost savings. An EC2 instance for a normal kind of use case could be at least $900 a month, but you get 100 times less cost through the use of LoRAX. And so Predibase is the platform that manages a lot of these infrastructure problems, the GPUs, training with deep speed for efficiency, out-of-memory exceptions, graceful restart, fault tolerance, right-sizing resources. These different infrastructure layers is the business of Predibase to provide and simplify, to give a simple SDK to developers. It's a hosted LLM fine-tuning and serving platform, draws from Ludwig, runs on LoRAX. LoRAX is inside and hides the complexity of provisioning compute resources, including the GPUs. And we will use the Predibase SDK today for fine-tuning Phi 3, recently released, on the Gretel AI text to SQL dataset. So let's go ahead and step into the code. We start with installing the Predibase SDK and the datasets library because we will be pulling the Gretel AI text to SQL dataset from Hugging Face. Now, some standard imports, connection to Hugging Face, and some utilities tokenization so we can decide how many tokens we need to output. And here we are going to use the Phi 3 base model. And this notebook, as well as two other notebooks, one for Mistral 7B, Instruct version 2, and also for Llama 3, are going to be available. This is in Google Colab, shareable. You can take them and run it for yourself. The links will be in the resources. Here we'll just go through Phi 3. And what happens here next is, here's our prompt. We want to fine-tune Phi 3 by asking it to give us the SQL, given the textual prompt, and additional information like schema and other knowledge about the domain of interest in the data set. And we subsampled the 100,000 row data set to get 20,000 high quality examples that we will use for fine tuning. You can try different numbers and see what results you get. And the key thing, after you initialize the Predibase with a token, with the API key, you can then create the client for the base model. And then you prompt the base model to see how it does, and then fine tune the adapter. So here's how we pull the data set. And I'll skip the rest of the operations. I encourage you to go through them. This is important detail of familiarizing yourself with the data, and then getting the correct training and test sets for yourself. This is an important detail, but it's all in the notebooks. I'll skip it and get straight to the actual prompting and fine-tuning. And so here, you'll run some statistics so that you know the number of tokens you need to have. And with all of that done, you upload the data set to Predibase. And then you prompt the base model to see what it does. So this is Phi 3 base model output, gives us some SQL for the prompt. What is the minimum duration of workouts for members who joined in 2010? 19 grouped by gender. But then if we're not satisfied, we run a number of examples and we find that one could do better. This is the call to fine-tuning with Predibase. You give it the base model, the data set, the adapter name, and the number of epochs, 3 to 5 should be sufficient. And it will run this, and you can observe the training curves in the Predibase UI, in the Predibase application UI. And once fine-tuning is finished, then you can prompt the adapter. And so that's what we did here. And that's the result of fine-tuned adapter. It's SQL. And you can compare against the ground truth. And later we will actually run the BERT benchmark on it. So that's kind of the flow of the code. And you can experiment with it yourself. And now I'm going to talk about the some of the resources that we have for you. So first, Predibase gives you $25 of free credits, so you can start experimenting with fine-tuning and efficient serving. And the 3 notebooks, the 5.3 one I just went over. There's also Llama 3 and Mistral 7b Instruct. All of these notebooks are available for you to experiment with. And we would love for you to join our Discord community. There are vibrant conversations about Predibase, as well as the open source libraries Ludwig and LoRAX. You can email us. We would love to talk to you about LLMs, fine-tuning, machine learning in general, vibrant Discord community.
All right, so Alex and I talked to you about using Gretel and Predibase, and so now we come to a point where we're tying it all together. So we have the text-to-SQL data set, we're able to fine-tune a custom model, and so now that we have done it, let's see what the results look like. Alex, if you can move to the next slide. So the experimental setup here is, as Alex mentioned, we're using only 20,000 samples from the overall 100,000 text-to-SQL dataset, and we're doing this just for demo purposes. We're leveraging the BERT SQL benchmark. BERT SQL has quickly emerged as the one of the best benchmarks to evaluate on text-to-SQL tasks. You see a description here on the right, but really it's a massive data set. It contains over 12,000 unique question SQL pairs. There are also actual databases attached to all of this. The full site of data set is 33 gigabytes. And so what one can do is use this independent benchmark, right? Because that's what we're trying to do. We're trying to evaluate how well does this work on the data set. So this is not a benchmark we're designing. We're also not looking at the BERT SQL trained data set. Like we could have trained on the trained data set as well. We trained just on Gretel data alone, so we can see direct lift from Gretel. We're evaluating on the dev set, and typically the way this is done, once you have things ready to go, you can also evaluate on the test set, then is published publicly on the leaderboard. So Alex, let's move to the next slide. These are the results. So we actually looked at 3 different families of models. We looked at the latest Llama 3 series, we looked at 5.3, and we looked at Mistral. And what's interesting, here we're looking at the EX score, basically accuracy score. Are we able to generate a right SQL to answer the question? And we're seeing a tremendous lift for all models. But what's interesting is that we're seeing a really sizable lift for Llama 3. We will be doing follow-ups, but Llama 3 is one of the latest models. It's definitely a capable model, one of the best out there, but you do see a pretty sizable lift for Phi and Mistral as well. An important consideration to keep in mind is that these models are not quite created equal. There is a lot more focus on quality of data for Phi and for Llama series, and Phi itself, unlike Llama and Mistral, is a much smaller model. It's actually a 4 billion parameter model, whereas Llama and Mistral are 8 and 7 billion respectively. And so when you look at the darker colors here, this is the final performance. The arrows indicate what happened when we took the base and were able to fine tune. So At the tip of the arrow is the final fine-tuned model. And what you see is that the final score, it looks like Llama is doing the best, followed by Mistral, followed by Phi. But again, Phi is one of the smaller models. Alex, let's move to the next slide. Breaking this further down, what BERT SQL allows one to do is to evaluate on various complexities of SQL. So there are questions that are in the simple category, moderate, and challenging. And what's interesting here is that we're seeing a bigger lift for more difficult questions across the board. And we're seeing, as expected, kind of bigger lift for Llama and Phi. Next slide. And then looking at the overall lift, just by leveraging Gretel synthetics and fine-tuning with Predibase on a pretty small data set, right? We could be using more data. We also could be generating additional synthetic data. This is just with one data set that we published, we're able to get pretty substantial lift for all of these models. So you really are able to take an off-the-shelf model, generate high-quality synthetic data, use the best-of-breed fine-tuning stack to get a custom model that does really well. And so this is, I think this concludes our workshop. Let's move to Q&A questions. So let's see. Alex, can you move on to the next slide? I think we already have some questions populated, and this includes questions that were submitted before the webinar. So we're going to try to get through as many questions as we can. So the first question is how to utilize synthetic data without incurring model collapse. This is a great question. For those in the audience not familiar with the model collapse, there have been several publications recently and several studies kind of ringing alarm bells about what happens if models, large language models, are trained on data that is generated by LLM models themselves, right? And there's this notion that you could theoretically be forgetting a lot of the underlying distribution in initial data that was used to train these models. And so as a result, the models would degenerate when trained. Now, this is a great question. It's actually, the question is not about synthetic data necessarily. I think this is a general question because the issue of the model collapse is really an issue of a feedback loop, right? And feedback loops in general exist and are known in quite a few ML applications. Recommender systems is a great example where you're using data that is being generated by users, let's say, coming to the site, right? You train a recommender system on that, and then you show recommendation to them. And what you end up doing is you create a feedback loop that affects the behavior of the users. And so that data, that new data then is used to retrain the model, and you constantly basically shifting distribution. So in that regard, the concerns about the change in distribution are not specific to synthetic data, but feedback loops in general. But what's interesting about synthetic data is that A, you have the levers to control what happens with the distribution of data, and B, at least the studies that I'm aware of, are really looking at using data blindly to train models. That is not the future we're building at Gretel, and that's not what people typically do in practice. You don't just generate data and train on it. There are a lot of checks that are put in place, and certainly evaluation is key here. You want to make sure you generate high quality data, and you are on the lookout for changes in distribution. So I think the key here is really to be doing evaluation, right, and not using synthetic data blindly. All right, let's move to the next question. Okay, it's actually, so this one, we're grouping them all together. How can I get synthetic data for non-code generation tasks? Can you make synthetic data for email and SMS forensics investigation? Is it possible to generate synthetic patient data for an EMR like OpenMRS? So these are great questions. Even though this webinar is focused on text-to-SQL, Gretel is not just about text-to-SQL, right? You should be able to generate any kind of synthetic data for any specific task. One to call out here that is quite different, or probably two, both with respect to email, forensics investigation, and EMR data. Personally identifiable information is something that you may not want to include, or in certain cases you may want to include, right? And the idea, how do you do, the question is, how do you do this safely? And so this is where Gretel actually shines because of the differentially private techniques that we have developed as well. So we we did not touch on that in this workshop. There are additional resources. Feel free to check out our website. But what Gretel is able to do is generate synthetic data that is differentially private by design. So you can actually work in heavily regulated industries, be it finance or healthcare, and generate high quality data. Let's move to the next question. What is the future of synthetic data in regulated environments? Okay, I think we maybe touched on some of this. I think that future is bright because when it comes to heavily regulated industries, there are several things happening. There's all the additional legislature that is coming out, be it the executive order from the White House on AI, be it legislation from the European Union. But one has to be careful about using PII data, right? That's typically one of the biggest considerations in regulated environments. And synthetic data becomes one of the key levers when working in a heavily regulated industry, because you are able to generate data that has the same, if not higher utility as real world data. And really our goal is to have much higher utility without having PI data in it. So you're able to build those classifiers if you want, or you're able to fine tune a model for your specific task without that model being compromised. And that's a really important consideration, not just in these industries, but for enterprises as well. You really don't know how models will be used and what attackers will be trying to do and what kind of vector of attack they'll be trying to leverage, what compute resources they have. So it's really important to be working with a differentially private solution as opposed to just trying to anonymize the data. Just because you strip something out from your data set, you still have all the other data in that data set that might make it possible to identify individuals based on either patterns in that data or that data being combined with another data set that your attacker might have. So synthetic data really allows one to address that and have mathematical guarantees in place around the identification. All right, let's move on to the next. Does Gretel work with Databricks? So as I showed very quickly in the demo, yes, Gretel is environment agnostic in the sense that you can use it directly in your code, right? We have the SDK available. You can use it in Databricks if you want it. All you have to do is just pip install Gretel client and you're ready to go. Yeah, so the short answer is yes. Next question. Okay, what sort of benchmarks have resulting synthetic data sets being assessed against? So here we're talking about the text-to-SQL data set. As you saw, there were several benchmarks. So I quickly mentioned us using LLM as a judge technique, and really it's not an LLM that we developed, it's the third-party LLM that is a very strong LLM judge. And we're comparing data set to another very heavily used data set. There are a lot of models trained on it, and we're able to essentially use LLM as a judge techniques to zone in on specific aspects of the data that are important. Things like instruction following, things like SQL correctness. That was one of the benchmarks. And the other benchmark we discussed in this workshop, and that was the, again, totally independent benchmark called BERT SQL, which allows us to evaluate on an entirely different data set the performance of our fine-tuned model. And that's why we're able to demonstrate the lift in performance. Next question. All right, Alex, do you want to take this? I think this is, I guess there are two pieces here. We touched on the synthetics. I think synthetics are key here in terms of developing custom models and solutions for the enterprise. But then the other piece, as we mentioned at the beginning, is really being able to not just fine-tune, but serve this. Alex, do you want to touch on those?
And this is a very good question, and it's at the heart. While most of the science, mathematics, and a lot of engineering has gone to the training part in machine learning. That's where all of the optimization techniques come into play. The propagation of the errors, the gradients, all of that to update the weights. It turns out that serving is actually what really impacts the budget once you put these models into production, because serving happens at a much, much greater cadence than training. You train when you got some new data, you want to improve your model. Yes, you do that depending on your application, but serving to your users happens constantly. And so it is very critical to understand your business's needs of serving. How are these LLMs incorporated in your particular application? What do they do? Do they help serve product recommendations, or do they help somebody write better Python code? Whatever the use case is, do they summarize news or generate marketing copies? It's important to understand the cadence of serving, and then understand the budget and pick the platform that is the most reliable when it comes to the quality, ease of use, and cost effectiveness. Obviously, we believe that Predibase shines on all three, but these are the kind of considerations that one has to do. One has to do capacity planning and work with a partner like Predibase, who would deeply care about success of their customers when it comes to taking advantage of LLMs in the real applications, who are really invested with the customers. So the next question is, does fine-tuning work for specific domain tasks, such as resolve an issue with product, my troubleshooting step by step using domain knowledge? So to interpret this question is, does fine-tuning work only for specific domains or across different domains? This is a great question, because the answer, as always in machine learning, depends on the use case, the data sets available, and the goals. I think that it is critically to work with your data set with a deep knowledge of your own domain to best create the fine-tuning data set that will achieve the results you want. Not all data set cleaning and filtering operations are the same for every use case. Customer support auto responses may be one thing, and a medical, the report, the note summarization may be something else. General news may be yet another thing. For SQL, we see yet another way of creating the data set. So deep knowledge of the domain, plus the tools in the data exploration, data engineering, to come up with a kind of a quality of the data set that makes sense for your application is the key. And then to see the results, get the feedback, and iterate. As LLMs are getting smarter, if you have deadlines to meet, instruction fine-tuning is more feasible than traditional fine-tuning. What are the methods to meet the LLM required target while keeping deadlines intact? So with this question, if I can paraphrase it, if you're in a hurry, you need to show something, maybe proof of concept, and fine-tuning maybe don't have time or to figure out how to do it or to learn platform, and traditional full fine-tuning is completely out of the question. What can you do? Well, what you can do is experiment with the prompts. You start with a basic prompt and you see how it does. Then you can increase the complexity of the prompt. You can increase it to, for example, include an example of how it would be. So it's kind of a one-shot and like one-shot learning example, or you can increase, make it more examples, or you can enrich the prompt with some more specificity depending on what you want. I think that with this approach, you can even include contrastive examples, the positive and negative of what you're trying to achieve in the output. So you are here sacrificing cost for time. You will probably get to some results quicker for your proof of concept, but you will be increasing the size of the prompt, which if you're using a commercial model it's going to cost more because there are more tokens. So that's the trade-off. But at least it can guide you towards what your application needs, and then you can take a step back and come up with a much more cost-effective approach, which is fine-tuning an open source large language model, much smaller, and it's available for you to use under your own control with your data set. Let's go to the next question. Okay, this is a question for Yev, right? It's a question about synthetic data.
Yes, and let me read it. How many interactions on average does it take to generate high quality synthetic data for training LLM, assuming each one will cost an extra GPU? Yeah, it really is use case specific. Gretel Navigator produces high quality data out of the box, and typically the challenge that we see is that when people are trying to generate synthetic data, they try an initial prompt, and then they realize, oh, I forgot to include this specific thing that is actually relevant for my use case. So it could be a business consideration, some sort of business constraint or model constraint or feature constraint that they're building. And so the short answer is definitely not one iteration. You're not going to get the data that you need with that one iteration. And so we really try to emphasize this design and iterate approach to data, right? You don't need to do things in one shot. You can very quickly iterate on the exact data that you need. And once you're ready to go, that's when you will generate as much of it as you need. So in that sense, the extra GPU cost doesn't really come in if you just follow some of the best practices. But yeah, we typically see clients do at least multiple iterations to really zone in on their specific use case. Next question. In text to SQL, if the question is, can I find t-shirts under 100, but in my database, it's named as t-shirt, how can we handle this kind of question? Okay, so I think this question is about an actual production feature, production use case. And so typically what you would do is you would leverage database context, right? So you would fine tune the model when you fine tune the model, I think that your ideal use case is to actually fine tune it on your specific database context. And so you would have these database definitions, right? So that if there is a column in one of your tables that's called t-shirt, then you're able to supply this via the schema. And I think depending on the model you use, if you're leveraging an LLM, for example, or a small language model, that small language model is actually able to pay attention, also bring in all the external knowledge that it already has, all the other data has been trained on. And so typically it wouldn't be an issue to figure out that you're looking at t-shirt with an underscore as opposed to t-shirts with a dash. Tokenization itself here helps too to map these. I think what you want to do is make sure you bring in your database context first and foremost, and then there are also retrieval augmented generation use cases where you can supply that additional context when you're making a call if you're using an LLM. And so there are many different ways to go about this.
If I may add also is that if you're using this directly to run this SQL, then yes, you definitely care about this precision. You want to be meticulous. However, if you're using it as a copilot, the system will probably guess enough of a correct flavor of the answer to give you the hint, since you already know your own schema, your data set. So it'll go such a long way that you'll probably be satisfied in the copilot application.
Okay. How much text data would we need to build a strong LLM of our own, not fine-tune an existing one? Can Gretel Navigator get us that much data? So this is a great question. What we discussed in the workshop today is fine-tuning a model, and I think you're roughly looking at an order of magnitude difference. So today we used 20,000 records. Anything you're training from scratch obviously depends on the size of the LLM that you're looking at, right? How many parameters does that LLM have? It totally varies, and also varies on the application, how complex the application is. But I think it's roughly an order of magnitude difference, if not more. So you're looking at hundreds of thousands of records to millions. Fine-tuning is definitely a lot less compute intensive and data intensive. And yes, Gretel Navigator can help you generate anywhere from just a few records to hundreds of thousands or a million records. So the short answer is yes.
This slide has two questions. One, are there intense hardware requirements to fine-tune with LoRa on Predibase? And number two, can you think of an example use case where it would be best to fine-tune an open source LLM in the financial services industry? Let's answer question one. When you fine-tune with Predibase, all of the hardware considerations are abstracted from the user. Predibase will use the underlying frameworks. I mentioned that Ludwig open source is a big part of the architecture design, and LoRAX for efficient service is in Predibase. These frameworks and the components around them handle the GPU allocation, graceful restart from out-of-memory exceptions, finite precision floating point numbers, right-sizing the models to fit in multiple GPUs or one as needed, sharing. All of that is handled by the platform such that the users, the customers, get at least 1/100th of the cost as compared to the direct large model alternatives such as OpenAI. So all of these requirements are abstracted from the user. Obviously, you can take the open source libraries, the Ludwig and LoRAX, and operate them yourselves. That is when you do have to consider the costs of these instances. However, with Predibase platform, it's extremely cost effective for the usage price at the token per token pricing. You get extremely attractive trade-off. And that is why we give away $25 of free credits so that you can try and see it for yourself. Now, an example use case from financial services industry, I do not have right now. If we don't have it, we'd love to collaborate with you to create one. We can think of a number of them that have to do with anomaly detection, like fraud, or some kind of a summarization of trends. So we would be very curious. Please join us in Discord, ping me, and we can work together on that.
All right, I think we have one more live question that didn't make it into the slides. I just wanted to very quickly read it out loud and address. Brian, so someone is asking how to make sure the data set is diverse enough. So that's a great question. There are two things. One is Gretel Navigator, being the compound AI system, already does quite a bit in terms of diversity so that you get as diverse data as possible. However, an additional really important control is on the user side as well, right? So again, we're talking about designing the data set. And if you saw in both the slides and the demo that I walked through, this concept of seeding your data, right? Like specific things you're trying to affect. And maybe, it could be diversity. It could be you wanted to generate data for a specific class that is currently imbalanced in whatever you have. You have that additional lever to introduce diversity. And so I think between these two, you were able to generate a data set that is quite diverse. All right, so with that, we are at time. I wanted to thank everybody for coming to this workshop. I also wanted to thank folks at Predibase and Alex specifically. Thank you so much for participating in this workshop. As a reminder, all the resources you saw today will be available afterwards, and there will be a recording of this workshop too. Thank you, everyone, and see you soon.